Hello students, welcome back to physics sessions. Today we are going to discuss laws of motion. We are going to discuss the laws of motion with concepts, tips and tricks and previous year MCQs with the solutions. Students, you can download our app Spark Academy. So you can join us for free live classes daily. There are daily live classes, in-session doubt clarifications, free material in our app, tips and tricks. The concept discussions are with tips and tricks, and previous year's questions will be included. So admissions are open right now. Classroom and as well as online coaching is available, and coaching for short-term crash course and for regular batches. Students, in a week, our physics sessions will be on Tuesday and Friday. So physics sessions in a week, 2 days, that is on Tuesday and Friday. So join with us for regular updates. Students, myself Sandhya. So I will be helping you the concepts of laws of motion and to deal the numericals related to Eamcet, JEE and Neet. Students, if you are buying any course from the Spark Academy, you can use the coupon code. So you can enter the coupon code as SAN10. You will be getting the 10% discount by entering this code, and you will be supporting me by using this coupon code. So let us go to our session plan. Today we are going to discuss from the laws of motion, Newton's laws, equilibrium of a particle, common forces in mechanics, and free body diagram. Laws of motion chapter. In this chapter, we are going to study the effect of force on body. Effect of force on object or a given body of mass m. We know that force is the cause of motion. And we will be discussing what are the important forces in mechanics and how they can affect the object motion. So that concept in the laws of motion we will be discussing. So let us start our today's session with the Newton's laws. So here our concept is Newton's laws of motion. Newton's laws of motion, first law. A body continues to be in a state of rest or of uniform motion unless it is acted upon by some external force to change its state. And this first law, it is giving the qualitative definition of the force. So it is giving qualitative definition of force. Means without applying external force, the body continues to be in the same state, whether it is at rest or if it is in uniform motion, it continues to be in the same state. So in a state of rest or of uniform motion unless it is acted upon by some external force. So to change the state, external force need to be applied. And the first law is also called as law of inertia. It is also called as law of inertia. And second law is the law of force. The force, net force or external force acts on object is equal to rate of change of momentum, which will be equal to mass into rate of change of velocity. So it can be written as that F external or net will be equal to mass into net acceleration of an object. And this expression is for constant mass. When there is a net force acts on object, for constant mass, we can write m into dv by dt. And the second expression, which is given as F bar is equal to d by dt of mv, and also can be written as F bar is equal to m into dv bar by dt plus v bar into dv by dm by dt, which is for variable mass. This expression can be used for this form for variable mass, such as this type of we can use this expression in case of rocket propulsion, such as rocket propulsion. So in the rocket propulsion, after it is fired, fuel mass is consumed. So there is a mass variation. Then we can find the applied force and what is the change in speed also. So for variable mass, we can use this expression. So this law is the second law of Newton's, is also law of force. So mainly, the net force acts on object will be equal to mass into net acceleration of the object. Third law, to every action there is an equal and opposite reaction. For example, we are walking, swimming, a horse pulling a cart, etc. Means in these motions, for every action there is an equal and opposite reaction, like FAB is equal to minus FBA. These forces cannot balance each other. They will act on different objects. Action will be equal to minus reaction. They act on different objects and simultaneously they do not cancel each other. That is the third law. So the third law is also known as law of action and reaction. First law is law of inertia. Second law is law of force. Third law is law of action and reaction. Next one is, our next concept is equilibrium of a particle. Equilibrium of a particle, when a body is said to be in equilibrium, if no force acts on the body, or you can see in another way, that is, sum of the forces acts on object will be equal to 0. So the net force acts on object is equal to 0, then body is said to be, means forces, if the sum of the forces along x direction, the sum of the forces will be equal to 0. If they are acting along y direction, sum of the forces in that direction will be equal to 0. And sum of the forces along z direction will be equal to 0. Then it is said to be in equilibrium. And the equilibrium of a particle is obtained as stable equilibrium, unstable equilibrium, neutral equilibrium. Sum of the forces acting on object equal to 0 means, we can say here acceleration is equal to 0. Means velocity vector is constant. velocity vector will be constant when its velocity 0 means when it is at state of rest, or magnitude of velocity constant. So velocity vector constant, it will be constant in these two states, whether it can be at rest or it is in a uniform motion. So we can say here, if velocity remains constant, then the change in velocity will be 0, acceleration is 0. So the first state, an object which is unable to move from its rest position. So in that case, potential energy is constant. That equilibrium state is called neutral equilibrium. Though forces acting on that object, it is at rest position only. So that equilibrium state is called neutral equilibrium, or it is also called as static equilibrium. In the static equilibrium case, potential energy is constant, that is d square u by dr square is equal to constant. Stable equilibrium, let us see the stable equilibrium. For example, an object initially at some state is displaced to some other position, it can come to its original state. It can regain its original state. In that case also some of the forces acting on object will be equal to 0. That equilibrium state is called stable equilibrium. For example, potential energy stored in a spring. Spring has the elastic nature. If it is displaced by an x, it can regain its position. So the potential energy is minimum, that is d square u by dr square will be equal to positive. So in a stable equilibrium state, if an object is displaced to other position, it can regain its original position, that is stable. In that case, potential energy is minimum. So d square u by dr square equal to positive. Unstable equilibrium, if object is displaced from its original position, it moves along the direction of displacement, and some of the forces acting on that particle will be equal to 0. Means as it is moving, it is gaining the speed. It is unstable equilibrium, means it will not come to its original state. The direction will be along the direction of the displacement. That equilibrium state is called unstable equilibrium. Here potential energy is maximum. d square u by dr square will be equal to negative. This is the equilibrium of a particle. Our next concept, let us see some common forces in mechanics. First force is gravitational force. Gravitational force will act vertically downwards near the surface of the earth. Let us see with the free body diagram. There is a mass. Let us treat that mass as a point mass. So its weight of that body will act downwards due to gravity. So gravitational force direction is vertically downwards, which is perpendicular to the surface of the earth. And next force is normal reaction. Normal reaction is the force which is the reaction force which will act perpendicular to the surface. Let us observe here, we are given with the horizontal surface. Object is placed on horizontal surface. Gravitational force, due to gravitational force, its weight acts downwards. Opposite to the reaction force, which is the normal reaction force, it is being perpendicular to the surface. Normal reaction perpendicular to the surface. Even gravitational force also perpendicular to the surface. It acts vertically downwards. For example, we are given with the inclined surface. Object is on inclined surface. Normal reaction force It is the type of contact force which will act perpendicular to that surface. Where object is in contact with the surface, their normal reaction force will act, which is perpendicular to that surface. For example, we are given with a curved surface. We are describing object motion in this surface. Now here, weight will act downwards like this. And normal reaction will be, at that point, draw a tangent. And for that, normal reaction will be perpendicular to the tangent line. So with different surfaces, we can observe here the direction of the normal reaction which is being perpendicular to the surface. Next, tension. Tension which will always act along the string. Example, see here. An object is suspended with the help of the string from the rigid support. Here, the tensional force will act along the string. For example, we are given with object is tied to the string this way. Along the string, tensional force will act. And now, on the surface, it is tied to the string. Along this direction, tensional force will act. It will always act along the string. Next, friction. Friction is the force which opposes the motion between the two surfaces in contact. Mainly in this laws of motion concepts, we will be discussing two types of friction: static friction, kinetic friction. Static friction has limiting value. Kinetic friction value is equal to mu k into n. For example, an object is placed on the surface. There is an applied force on object. With this applied force, object has the tendency to move. To oppose that motion, at the contact surface, frictional force will develop opposite to motion of this object. So this friction will increase up to its maximum value. If we are increasing, applied force is increasing. So frictional force also will increase up to this value. When frictional force is equal to, means till that value, it opposes the motion of the object. When it reaches the maximum value, means the applied force is being equal to F maximum, then the body has the tendency to move. If it is greater than that value, applied force is greater than F maximum, then the body will accelerate. Then the kinetic friction plays a role in that situation. The kinetic friction will be given as mu k into n. So frictional force always depends upon the normal reaction force, which will be equal to mu into n. So the limiting value, the static friction has limiting value or maximum value, which lies between 0 and mu s n. When applied force is greater than that maximum value, kinetic friction will come and play the role in that situation. So if we see the graph between applied force and the frictional force, so linearly it will increase up to maximum value. So when the body starts accelerating, kinetic friction will play. So Fs, and in this situation, Fk. So at these points, we take their coefficients. So where mu s is greater than mu k. Means in which case we need the more applied force, means which is in the state of rest. To move that object, we need to apply the more force. If it is already accelerating, the applied force is less than this situation, the body which is at rest. That is what mu s is greater than mu k. And the next type of force is spring force. to bring the spring to relaxed state. Let us see here, the spring is under deformation by the application of the force. So it is the pressure to left side. The restoring force experienced by the spring will be in opposite direction. So which restores in its nature, spring has elastic nature. So the force experienced by the spring is equal to minus Kx. So this minus indicates restoring force due to restoring force. So if it is under deformation to left side, F by the spring will be right side. If it is under deformation in right side, force experienced by the spring will be left side, opposite side. So this is the magnitude of force experienced by the spring. So due to restoring force. Next, weighing mission, which measures the force experienced by the object on the upper surface of the machine. Let us see. We have the apparatus, which is the weighing machine. So inside the machine part, that apparatus measures the weight of the object which is placed on that. Here, if there is a person standing on the weighing machine, so it can give. So weight of the person will act downwards, and there will be the normal reaction force. So this reaction force gives the weight of that object or the person which is placed on that machine. That is equal to mg. In this case, it is an equilibrium position. This situation, if the weighing machine or the person which is placed in the lift, if the lift is accelerated up or downwards, then we can find the apparent weight of that person as the lift is accelerating. We will look into that situations also. Next type of force is spring balance, which measures force experienced by the object at the hook of the object, at the hook of the machine. Means the apparatus will have, which is calibrated with the scale, it is provided with the spring, and here we hang the objects. So that weight will act downwards. It shows the reading in that scale. So it measures the force exerted by the object at the hook of the machine. Our next concept is free body diagram. Free body diagram is helpful to find the resultant force, and acceleration of the system. One of the very important concepts. So by drawing that free body diagram, we can solve or we can find the force and net force and acceleration of the system. So here we are given with the different cases in different situations. With the help of free body diagram, now we are going to find the required force and the acceleration of that system. So free body diagram is used to draw visualizing the direct forces acting on that object. We just draw. Let us see in the first diagram. In the first diagram, we are given with the two masses tied to the string which goes over a frictionless pulley. So let us draw the free body diagram of N1. So we just draw in the free body diagram direct forces acting on the object. Balanced forces will cancel each other, only action forces in the direction of motion. What are the action forces we draw? So we treat that point mass, that mass of the object as point mass, and for M1, weight will act downward and tensional force is along the string, which is upward. So if you apply the Newton's second law for this situation, So direction of M1 is showing upward, it is accelerating up, whereas M2 is greater than M1. So we can write here the force which is along the direction of motion, that is positive, opposite to direction of motion is negative. Now T is along the direction of motion, so T minus M1G. M1G is weight force, T is the tensional force, will be equal to net force acting on that object. Net force is mass into acceleration. So this is the equation 1. And draw the free body diagram of M2. Here, treat that object as point mass M2. Weight will act downwards. Tensional force is along the string. Now, acceleration of this object is showing downward. So, the resultant force acting on this object will be M2G. M2G is along the direction of motion, so plus. T is opposite to direction of motion, so minus will be equal to M2 into A. So in this situation, we want what is the acceleration of the system. As a whole, the system moves. M1 and M2 as a whole can have the common acceleration. So take them as equation 1 and equation 2. So if you substitute to T value in any of the equation, you find the acceleration as M2 minus M1 by M1 plus M2 into G. And we have to find the tensional force also. In this situation, they can ask, find the common acceleration of the system and find the force, which is the tension acting along the string. So the tension will be, after finding A, substitute any of the equations in 1 or 2, T will be equal to 2M1 M2 by M1 plus M2 into G. So you can remember these derived results, or you're not familiar with these derived results, means then free body diagram help to solve the situation. So you just treat that mass, for each mass, draw the free body diagram, simplify that equations. Let us see the case 2. There are 3 masses M1, M2, M3 are connected with the strings as shown in the figure and lie on a frictionless surface. They are pulled with force F attached to M1. So let me draw the free body diagram of M1 first. On M1, this is M1. Treat that as a point mass. Along the direction of motion, applied force. In this direction, T1. So we can write net force acting on that object will be equal to F minus T1 is equal to M1 into A. Next, draw the free body diagram of M2. So on M2, along the direction of motion, there is T1, and here in this direction, T2. So net force acting on M2 means T1 is along the direction of motion, T2 is opposite direction, so minus T2 is the net force. Net force means its mass into acceleration. As they are connected with the string, they can have the common acceleration. Next, free body diagram of M3, there is only force, only direct force we need to draw in the free body diagram. So direct force is T2. So resultant force acting on M3, we can write it as only T2, which is equal to its mass into acceleration. So from all these 3, acceleration of the system will be equal to F by, they can have common acceleration. From the second law, F equal to ma. A is equal to F by m. Here m is nothing but total mass, m1 plus m2 plus m3. And next, they can ask what is the T1 value. So substitute A value in equation 2, this is equation 2, this is equation 1, this is equation 3. Substitute A value in equation 2, we get it as, and you can also think T1 is acted upon by M1. So it can affect the M2 and M3. So it will be equal to M2 plus M3 by M1 plus M2 plus M3 into F. Next, T2. T2 is acted upon by M2, which can affect the M3. So with that force, it is pulling M3. So we can write M3 by total mass M1 plus M2 plus M3 into F. So by this way, you can remember acted upon by which object, that mass will not come here. The remaining masses by total mass into applied force. Or you can simplify from these equations, you will get the required force which is acting at that situation. Let us see the next situation. There are two blocks of masses M1 and M2 suspended vertically from a rigid support with the help of a spring. In the figure, M2 is pulled down with a force F. And they did not give any acceleration of the masses. So here they can ask, just to draw the free body diagram of both. About M2 we draw. M2 treat that mass as a point mass. On M2, there is an applied force and tensional force. So in this direction F, comma M2G also. So this is balance. Tensional force T2 is balanced by these two. So we can write T2 is equal to F plus M2G. And draw the free body diagram of M1. So on M1, tensional force along the string, towards the string to the rigid support, and downward, this tensional force, which is T1, will be balanced with the total weight of the blocks. Means M1G plus M2G plus F. So T1 will be equal to, so in this situation, they can ask tension along the string. So T1 is balanced by applied force plus total weight, like M1 plus M2 into G. So free body diagram helps to find the required quantity. In free body diagram, always note a point. You must draw the direct forces acting on that. So it is to be drawn to visualize the direct forces acting on the mass. Case 4. Two masses M1 and M2 are attached to a string. One is placed horizontally, other is hanged vertically, connected to the string that passes over the pulley, which is the frictionless. So free body diagram. Let us draw free body diagram. So here, the system is accelerating downwards. It has shown with downward. So on M2, free body diagram, weight will act downwards. Along the string, there is a tension. Acceleration is downward. So net force acting on object means M2G minus T is equal to M2 into A. Like resultant force is equal to mass into acceleration. We are applying Newton's second law. Resultant force is M2G minus T, mass into acceleration. About M2, so it is M2 into A. As it is connected with the string, it moves with common acceleration. Both can have common acceleration. And about M1, free body diagram of M1. So just to draw the direct forces acting on that. On this only tensional force, as it is placed on horizontal. So resultant force is tension, which is equal to M1 into A. So if you simplify this, these two, substitute T value in above equation, common acceleration of the system is, so the acceleration is due to M2, so we can write M2 by M1 plus, like F by M, that F is M2G. M2 by M1 plus M2 into G. Next, what is the tension along the string? Substitute A value here. We get M1, M2 by M1 plus M2 into G. Our next situation, two masses, one is placed on inclined plane, other one is hanged vertically. Here also just to draw the free body diagram of, let us draw the free body diagram. In this case, let us take when M1 moves up on the inclined plane, moves up. And let us observe the component of forces acting on object when it is on the inclined surface. You can observe in the figure, normal reaction force perpendicular to surface of contact, weight perpendicular to the earth surface, like this, and this weight resolved into its components, M1G, if this is theta, here angle will be theta. It resolves into adjacent side is M1G cos theta, opposite side is M1G sin theta. Now, M1 has the tendency to move with this force. But we are taking the case if M1 moves up on inclined surface. So just to draw the free body diagram of M1. Here, when it moves up, along the direction of motion, moves up means in this direction. Direction of motion T is there. So this direction T, opposite to that T is balanced by M1G sin theta. So resultant force means T minus M1G sin theta will be equal to M1 into A. Next, second object, that is M2, its weight acts downwards, tension is along the string, resultant force, so when M1 moves up, it moves down, so we can write direction of motion is downward, so M2G minus T will be equal to M2 into A. So by simplifying these two, common acceleration of the system when M1 moves up the inclined plane, A will be equal to M2 minus M1 G sin theta by M1 plus M2 into G. And tension along the string will be equal to, substitute A value here in equation 2, take it as 1, take it as 2. So tension will be equal to M2 M1 by M1 plus M2 into G by 1 plus sin theta. This is the case when it moves up. Just to draw the free body diagram, write the resultant force, find the acceleration, substitute acceleration any of the equation, we can find the tension. Next, let us see if it moves down. M1 is on inclined surface, so if it is moving down on the inclined surface, so we need to take like this. It is on inclined surface in this direction tension, in this direction m1g sine theta. Downward it is moving means along the direction of motion m1g sine theta is there. So m1g sine theta minus t will be equal to m1 into a. And about the second object, now this time when m1 moves down, m2 can move up. Direction of motion will be that direction. So along that direction, tension will be there. So we can write T minus m2g will be equal to m2 into a. So let us write here common acceleration when m1 moves down. So acceleration will be equal to just by this note, when it is moving up, it is m2 minus m1g sine theta. When it moves right, m1 sine theta, like actually g will not be here, m1 sine theta into g. m1 sine theta minus m2 by m1 plus m2 into g. And tension, substitute a value in any of the above equation of the free body diagrams. Then we get it as, it will not change. Tension will be same. Along the string it is m2 into m1 by m1 plus m2 into g by 1 plus sine theta. Next situation is two objects on inclined surfaces connected by the string, and that string passes over the frictionless pulley. So in this situation, so let us take let m2 moves downwards. So m2, just draw the free body diagram of m2. We take that as a point mass. So as it is having angle of inclination, let me draw the component of forces here. In previous figure, we have seen component of forces. N2G will act downward. In this direction, normal reaction. So this weight force makes angle beta. If this is beta, this will also be beta. Makes angle beta with the vertical, with this normal reaction line. And this will be M2G cos beta. And in this direction, with this component, M2G sin beta component helps to move downwards on the inclined plane. Even same for the M1, weight will act downwards, normal reaction perpendicular to the contact surface, and this angle will be alpha. So it is M1G cos alpha, and in this direction M1G sin alpha. So we have drawn component of forces on that objects which are on inclined surface. Now let us draw the free body diagram. We consider M2 moves downwards. So now, so direction of motion is this way. In this direction, there is M2G sin beta. So along the string, tension will act. So this way, tension will act. So along the direction of motion, M2G is there. So M2G sin beta minus T is the resultant force on M2, which will be equal to M2 into A. Next, take free body diagram of M1. It can move upward when M2 moves downwards. So direction of motion is along the direction of tension, and opposite to that, which force is acting? It is the free body diagram of M1. So it is M1G sin alpha. So we can write here T minus M1G sin alpha, because Along the direction of motion, tensional force. Opposite to direction of motion, sine component. That is n1g sine alpha, which is equal to n1 into a. And if you simplify these two equations, acceleration of the object will be equal to m2 sine beta minus m1 sine alpha by m1 plus m2 into g. You just write separate t value, substitute any of the equation, and elevate the acceleration. And in the same situation, what is the tension they can ask? Tension means a substitute a value in any of these two equations of the free body diagram. So it gives you m1, m2 by m1 plus m2 into g into sine alpha plus sine beta. This will be the tension in this situation, which acts along the string. For example, they are asking what is the tension towards the pulley. Towards pulley, it will be equal to 2t. So next, let us analyze the case 7, a person or monkey climbing up rope. See the first diagram. Person climbing up the rope with an acceleration a. In this case, we can write a resultant force in this first situation will be T minus mg is equal to ma. So tension along the string or the rope, here it is rope, he is climbing up the rope, tension along the rope will be equal to m into g plus a. Let us see next situation. The person climbing down that rope, he is down the rope, then acceleration is downwards, so along the direction of motion, weight of the person mg, opposite to that minus t, mg minus t will be equal to m into a. In this case, the tension will be equal to, we can write it as tension m into g minus a. When he is climbing up the rope, tension along the rope is g plus m into g plus a. Climbing down, tension along the rope is m into g minus a. Our third case we can observe in the case 7. Third situation will be, they can ask the person climbing up or down with a uniform speed. He is climbing up the rope or down the rope with the uniform speed. Means uniform speed means that is acceleration equal to 0. Then the tension along the rope will be equal to weight of the person only. T will be equal to mg. So this is one of the situation. Next, let us go to another situation. Here, an object is at rest on the smooth inclined plane of length L at a height h and having angle of inclination theta. So let us write here height of the inclination in terms of distance traveled by the object. So from the figure, h we can write it as L sine theta. In this situation, the questions can be asked. First question they can ask like, so it is at rest, it has a tendency to move down. So while moving down on the inclined surface, what is the acceleration of the object? Here, we can just draw component of forces acting on that object, weight at downwards, normal reaction opposite to means perpendicular to surface of contact This will be mg cos theta, which is the angle theta. Here angle theta, here also will be theta. And opposite to angle will be mg sin theta. So that object can move down with the component of force mg sin theta. So we can write resultant force acting on that object while moving down is mg sin theta. Then acceleration will be equal to g sin theta, because we can write ma is equal to mg sin theta, gets cancelled. So while moving down, acceleration of that object is g sin theta. And they can ask what is the velocity to reach the bottom of the inclination. So it is like a freely fall object. As it is a smooth surface, it can slide with this component of force mg sin theta, and it reach the ground with this speed, like a free fall object, 2gh, but it travels length of the inclination, so we need to write height in terms of L, so which is equal to 2g L sin theta. That is the speed of that object when it reaches the bottom of the inclination. And they can ask what is the time taken to reach the ground. So time taken will be b by a. Here b is 2gh by a is g sin theta. So we can write it as 1 by sin theta under root of 2h by g, because g can be written as root g into root g. So 1 by sin theta into under root of 2h by g. So when an object is on smooth inclined surface at rest, it has the tendency to move down. So they can ask what is its acceleration, velocity, and time taken to reach the bottom. Next, ninth situation, weight of a man in a lift. We discussed in important forces of mechanics about the weighing machine, which measures the force exerted by the weight of the person on that machine. So here we are given with that weight of a man is in the lift. In the first situation, that lift is accelerating up. So we can write resultant force acts on the object. You can see normal reaction will be upward, weight will act downward. This normal reaction force only apparent weight of the person. We treat that normal reaction force is the, or reaction force gives apparent weight of the person who is in the lift, because along the lift he moves up or he moves down. So in the first diagram, we can write when a lift is accelerating up, n minus mg is equal to m into a, where m is mass of that man. So here n is equal to m into g plus a. So here actual weight of the person is true weight, which is given with the W naught, is mg only. But when lift is accelerating up, we can say where n is apparent weight, so apparent weight is being greater than true weight. Let us see the second situation. Lift is accelerating down. In this case, we can write mg minus n is equal to ma. Then n is equal to m into g minus a, where m is the apparent weight, is less than true weight, because mg minus m, you know. Next situation, if lift, let me give you, if lift moves with constant speed, v equal to constant. V equal to constant means acceleration 0. Then the resultant force, whether it moves up or down, With constant speed, acceleration 0, it will be equal to n will be equal to mg. Means that is apparent weight will be equal to true weight. This is the third situation for the weight of a man in lift. Let us see fourth possibility. If left is free fall, it is freely falling, means acceleration is equal to g due to gravity, either up or down. Usually it is down. Free fall means downward. So we can write here acceleration g means to put in these equations a value as g, then reaction force is being equal to 0, means that person feels when lift freely falling, he feels weightless. The person feels weightless. So with these four situations, they can ask apparent weight of the man in a lift. And last situation, we are given with the three masses which are in contact, and they're given what are the forces directly acting on that masses. So we need to find forces acting on that masses and acceleration of the system. As they are connected, they move as a whole. The whole system will move as common. So we can write from Newton's second law F equal to ma. From this, A is equal to net force by net mass actually. So in this case, net force is applied force, that is, or external force, F by m1 plus m2 plus m3. To find the direct forces acting on individual masses means you must draw the free body diagram. So for M1, in this direction applied force, in this direction F1. On M1, there is a force F1, but the direction of motion is along the applied force. So net resultant force means you have to write F minus F1 is equal to M1A. Let us take second mass, that is M2. On M2, F2 is acting in this direction, opposite to direction of motion, applied force. And F1 is acting in this direction. So we can write F1 minus F2 because F1 is along the direction of motion. This is the direction of motion. So F1 minus F2 is equal to M2A. And next is third mass free body diagram. The only force, direct force acting on mass M3 is F2 in the direction of motion. So resultant force on this will be F2 is equal to M3 into A. So from all these only the common acceleration we have written. So if they are asking individual forces, what is F1? F1 is the force directly acting on M1. So here we can write it is it will affect the other two masses. Then F1 we can write it as M2 plus M3 by M1 plus M2 plus M3 into F. Now F2 is only force which is acting on M3. So if you take free body diagram of M3 and substitute acceleration, we get it as m3 into F by m1 plus m2 plus m3. So just draw the free body diagram, find the required force. So students, download our app for great discounts on our courses. So in our app, free handwritten notes is available, free study materials, previous year's questions, and free mock tests. So link is given in the description. If you're buying any course for the admission, you can contact any of these numbers which is displayed. So the timings are given for the coaching, short-term, regular, and crash course coming soon. They'll let you know. So online coaching is for Neet, JEE, and Eamcet. And students, don't forget to enter a coupon code which is displayed here, SAN10. So by using this, you will get the discount, 10% discount on the course. And you will be supporting me by using this. So there are the daily and on-demand live sessions in our app. So our methodology is we start from right from the basic concepts, shortcut methods, all model questions, exercise questions, previous year's questions will be discussed, chapter-wise tests will be conducted, weekend tests will be conducted, grant tests will be conducted, and test analysis will be given after the exam immediately. So here are given information about the access to classroom and access to online. And let us discuss the previous year's questions related to today's concept, how to find the resultant force and acceleration of the system. Here, first question, on a smooth plane surface, two blocks A and B are accelerated up by applying a force of 50 newtons on A. If mass of B is twice that of A, the force on B is. So they're asking force on B. So take the free body diagram for B, FBD. So the only force will act on this B is contact force due to A on B, and for action, reaction due to B on A will be like this. So the only force, let us say, due to A on B is F on B. So we can say that it has in this B mass, F only force is F. So resultant force is F, which will be equal to mass into acceleration. And they are saying mass of block B is twice that of the block A. So we can write here twice that of A means 2m into A. And acceleration of the system will move as a common. Acceleration of the system will be F by mass of A plus mass of B, which will be equal to F is an applied force, means external force. So it is 15 by 2m plus m, it will be 3m. So 3 5s are 5 by m, substitute here 2m into 5 by m, cancel. So force acting on B, the force on B is 10 newtons. Next question, we are given with the two bodies which are in contact. One is 1 kg, other one is 0.5 kg. Applied force is on 1 kg, which is the external force. Acceleration of the system is positive x direction. And they are saying each block, here we are given with each block exerts a force of 6 Newton on each other. So here like this. Due to 0.5 kg on 1 kg and due to 1 kg on 0.5 kg, 6 newtons, here also 6 newtons, and here also 6 newtons. So for 1 kg free body diagram, in this direction F and in this direction, which is equal to 6 newton, by 0.5 kg in this direction also 6 newton. Here resultant force is being equal to 0. For free body diagram of 0.5 kg, on this means nothing but 6 minus 6 is being equal to 0. So 1 kg object is at the rest position. 0.5 kg on this, the only force acting on that due to 1 kg, which exerts 6 newtons. So resultant force on 0.5 kg is 6 newtons is equal to its mass into acceleration. Now the acceleration, so the block move with a uniform acceleration of means. Find the acceleration here. A is equal to 6 by 0.5, which is equal to 60 by 5. We can cancel 12 times, 12 meter per second. So need to understand the line. Each block also exerting a force of 6 newtons on other. Not only applied force here, each block exerting. And third case, it is a pulley system. The objects are connected over the pulley and connected with the string and passes over the frictionless pulley. And now we need to solve this question. They are asking 15 kg and 10 kg mass blocks are connected by light cable passing over a frictionless pulley as shown below. What is the acceleration experienced by the system? So this result we have already derived in the previous slide. That is, you can take direct relation. That is, acceleration is equal to mass of block A minus, here they are saying it is 15 kg. So 15 kg means downward, this side acceleration will be there and B moves upward. Though you have drawn the diagrams, the free body diagrams, acceleration we get it as ma minus mb by ma plus mb into g. So substitute their masses 15 minus 10 by 15 plus 10 into g, which is equal to 5 by 25 into, substitute g value, approximate value 10, 5 5 10 by 5 is 2 meter per second square is the answer. Can use direct derived result if you are not familiar with that, means not perfect with that, the derived result. Draw the free body diagram of each block, simplify that, you will get the answer. And next question, there are 3 blocks of masses m, 2m and 3m connected. After an upward force F is applied on block m, masses move upward at constant v. What is the net force on the block of mass 2m? So they're asking block of mass 2m. So let us take this situation with the free body diagrams. So FBD, first we draw for m, block m. What is the force acting on the direct force acting F, upward direction, and its weight acts downward. But this total applied force, we can say from the figure, will be equal to 6 mg. And now on 2m, take the 2m mass, upward in this direction, tension will act, and this direction, here tension will act, let it be T, and where the masses are different here, let it take the T dash. So here upward on 2m, there is upward force T, and downward it will be balanced with total weight. This T will be balanced with like 2m plus 3m into G. So on for block 2, T is balanced by this total weight because there is a 2m and 3m connected with the string. So it will be 5 mg. And we can write and tension is being equal to 5 mg. T value will be equal to 5 mg because for 3m mass, let us take T dash and downward of that like 3 mg. So T dash is equal to 3 mg and T will be equal to 5 mg. So for block M to T minus F mg will be equal to that total mass into acceleration. That is the net resultant, which is being equal to 5 mg minus 5 mg will be equal to 0. So students, this is a required discussion. So free body diagrams are very helpful to solve the situations for the connected bodies, contact bodies, bodies passes over the frictionless pulley. Here I given a few more questions. You can solve and post your answer in the comments. Thank you.